Okay, so let's talk about namespaces in a bit more detail. You remember that std prefix that we did, so std : cout. Again, that std is a namespace. So you can think of a namespace as a code block. Again, we've discussed code blocks before, containing a collection of named members, which can be classes, functions, variable declarations, named constants, and so forth. Again, we'll discuss members in more detail later as well. It's basically a member of something, so it belongs to something. So maybe it belongs to a class, that could be functions, variables, and so forth. So in this case, it's like a block of code that is also named, but it has classes and various other things in there as well. So you can start to see what's going on in C++. We have various ways of organizing things and what we do inside of these folders or these containers, which are basically just blocks of code between curly braces. Okay, so let's just move on here. You have something called a global scope, and this you can think of as an identifier. Now, again, this is something you'll hear often to identifier, or something that is named. So that can again be a function or something like that, or a variable, something with a name. Just like you have a name that somebody calls, or your pet or something, it has a name. Now, similarly, to reference something when you're programming, you have to attach a name to it. So you can think of that as an identifier. We'll talk about that in more detail later. So an identifier whose declaration is not inside a code block. Okay, so you can think of that as the global scope, because it's going to be accessible basically anywhere. You can access that stuff kind of where you want, because it's not between curly braces. And we'll talk about scope as well in a lot more detail later. But basically, if something is contained within curly braces, then you need some way of accessing that. Then that member, that thing that's in between those curly braces, are basically only accessible between those curly braces. It has scope in there, but it's not accessible outside of the curly braces. So again, if you take the curly braces away, then it's accessible globally. All right, so a namespace allows us to partition that global namespace, that global scope or space, into named subscopes or subspaces. And this helps reduce name or identifier conflicts. Okay, so moving on here, the C++ standard namespace is shortened here, so std, that stands for C++ standard namespace. So that is why we prefix cout with std, because it is contained within that standard namespace. And so here's a quick syntax again for accessing namespaces. You can see the namespace, so that is like the folder name. Then what is inside that folder? You have a bunch of files in that folder. So you can think of each file, the name of that file, as being the identifier. When you double click on the file, with that identifier, with that name, then that file opens. And again, similarly, if you have two files in that namespace with the same name, or if you try and create two of those in the same folder with the same name, then you'll get a conflict. But it makes sense, of course, to have two namespaces, two different namespaces with the same identifier, because you can just use the syntax to access whichever one it is that you want. So we can have two namespaces. So we have namespace 1 and namespace 2, and both of them can have a function identifier called greeting that can say hello or something else, and we won't get a conflict because they are, depending on how you access them. If you put them out globally, then you could still get a conflict. So you have to use these smartly. We'll see this shortly here, how we can, the different methods that we have to access these identifiers. But basically what happens here is you have this double colon, and this is called the scope resolution operator. What this basically does is, and we'll see this a lot going forward as well, when we get to classes and such, is this resolves that scope. It allows you to access something that is outside the current scope. You can think of it that way. So it's going to go from the current scope, and it's going to go inside that prefix, so the namespace, go inside of that scope. It's like double clicking on a folder, and then you go inside of that, and then you dig kind of in and go and take out like what you want, based on the identifier that you use. Okay, so I hope this makes more sense to you now, and like why namespaces are useful. It's a way for us to organize things, and it reduces name or identifier conflicts. Okay, so let's look at an example. I'll use folders to kind of demonstrate this. I'll create this folder here. I'll go inside that folder and I'll create a few files. So I have these few text documents. And so what is a text document? It is an instance of a text document. So you can think of these as objects. A class you can think of as the blueprint, what it means to be a text document. And the actual text document that we create, you can think of the object and, is an instance of a class. Don't worry about this too much. Again, we'll talk about this in more detail later. So we create this text document, and as soon as we create the next one, it is renamed automatically, and it adds this to, like postfix to this, so that the name differs, because each time it's just going to say new text document, right? So let's try and rename one of these. So I'll try and make this 2, so the same as the one that already exists. So I'm going to type 2 and click, and now get this error. Do we want to rename this thing to new document 6? There's already a file with the same name in this location. So I can say no, it's going to revert back to 5. I can try that again and say yes, it's just going to rename that to 6 then. And the reason is because we get a conflict. I'm trying to have 2 files in the same place with the same name. Okay, so let's close out of this for now. And I'm going to rename this to the global scope. So in the global scope, let's go inside of that. Now this is in the global scope. Okay, this might make more sense now, because all of this stuff is in the global scope. None of these files are contained within a folder. So of course we can break the global scope up into subspaces or sub-scopes. And we can do this like this maybe. And okay, so we have these 2 namespaces. And now what I can do is I can add these documents to one of those. And create a bunch of files. And so in the first namespace, I have something called new text document, just new text document.txt for text, or new text document 2. And I can have the exact same thing in this second namespace without having a conflict. Okay, and those are now in subspaces. So this is the global namespace. So how do we access these? Well, of course, in Windows, this kind of silly demonstration, you just double click on it. So how do we access that in C++? Well, we have the name here. Okay, we know this thing is called namespace 1. So you do namespace 1 followed by the scope resolution operator. That's like double clicking on that. So you go inside of that and then you say, okay, what do I want to access? What is the identifier or the name of the thing that I want to access? Well, let's say this file. Okay. Now in C++, that could be the name of a function, of a class, of a variable, or whatever else contained with, like, inside the scope of that namespace. Okay, so this kind of a silly example. I hope this makes more sense to you now that I've explained it in this way. I'll just delete this folder. Okay, another namespace demo for you. So I created a new project for this. I called it namespace demo. You don't have to do all of this on your end. I'm just again trying to explain to you the namespaces. Okay, so we have the main function. So again, the operating system calls out to our program looking for its starting point basically. So it goes to main and you have greeting. Now this, as you can see, is a statement. It ends with a semicolon. It has these opening and closing parentheses, just like main, but it doesn't return anything. It simply does something, so it prints something out to the screen. So we are not looking for it to return something, some value that we calculate, for example. So I'm doing that purposefully because we've already seen this hello this cout and all of this stuff. So we want to keep it simple. So of course it is a function. So it's going to start with main, then it's going to call the function. So execution is going to jump from main to here, and then it's going to execute this. Once it reaches this closing curly brace, it's going to jump back to main, and it's going to return 0 and exit. Let's just look at a few things here. Firstly, I'll run this and you'll see it works. It says hello, close out of that. Now you might wonder, if I go and cut this, paste that down here, run this again, we'll get errors. And you'll see here something says identifier not found. Okay, here with greeting. And so the problem with this is programming again is sequential. So it's going to read from the top down, and the program needs to know about your functions and so on before it actually uses them. The same with variables and all of that. So I'll be talking about this extensively as we go along, but basically we need to put this before we use it. So here we use greeting, but the actual definition of greeting is down here. So the program doesn't know about it when it reaches this greeting line in main where it calls the function, and therefore it will give us an error. So you have to remember always with programming here in C++ and in general really is that sequential execution that I talked about. It's important that we define that function before we use it. Okay, another quick note is, so I just copied that in and I'll just Control V again. So I'm just Control C, Control V to copy or Control X to cut. So don't worry about that at this point. I'll do a different video on that in this introductory lesson. So the point is I have these two functions now. Let's say I want to change one of those. Something like that, hello humans. So of course you have something called overloading, which I'll discuss in the future, where you can specify different parameters in here and then you can kind of use the same names. So the point here is we have two functions with the same name. You can see if I double click on that, all of those instances will highlight where you have the greeting name, okay, to make it easier for us to read and to see like what it is that we are interested in here. So again, you can hover over it, click on it once, and those instances will highlight. So here we are simply calling it, but here we have these two definitions. So of course you can think now, Control F5 to run this. Again, we have an error because we have basically two functions with the same name. Okay, so of course you can call this greeting1, greeting2, or human greeting, alien greeting. Okay, that could work. But sometimes you want the same name. It makes sense to have the same name. So this is kind of a silly example, but sometimes again it makes sense to have the same name. So what I'm going to do is I'm going to, firstly I'll create a header file just out of interest here. So I'll right click on that project name. So again up here the solution, you want to right click on the project, go to add new item, and I'll do a header file. So in this case I'll just leave it to header.h actually, and I'll just click on add. So we can leave this in here. It simply means include this file once when you compile. Talk about these things again in more detail later. So what I could do is I'll cut this function out and paste it in the header. And I'll just cut this out for now. I can paste it back in later. And now we have to include that file. We want to use it, so we have to include it here. So I'll do include. And in this case, we are not using greater than, less than operators. We are using double quotes instead. And as I type out, you'll see that our header shows up. So I'll do header.h. And now you can see we had a squiggly line here before. Okay, another thing I want to show you before I move on, and again, an excuse to show you this stuff, is save and save all. So we have the header file here. You can see I talked about this kind of yellow color here that shows up when we make changes. So when we save this, I'll just click on save, or you can press Control S. You will see that that goes away. I'd also like to note that in the tab, of the document here. Again, we have header.h, main.cpp. Now in main.cpp, you can see we have unsaved changes, and you'll also notice to the right of the name, you have an asterisk that shows up. Of course, that means that this file has not been saved. So it does not show up in header.h here because this file has been saved. Make a quick change here. You'll see that the color changes. Green indicates like what we have saved, so what's saved out already. And again, this yellow color shows unsaved changes. Okay, now in this header.h again, we'll see that asterisk show up. So you can save one or the other. If I save this file, it's only going to save this file. So of course you have the option to save all, because again, as I mentioned, this tab basically represents with the name at the top. This basically represents a file that's actually on your hard drive. So you have to save your changes to that. So you can save either this currently active file, the one that is highlighted at the top that you have open, or you can click save all. As soon as I click save all, those asterisks will go away, and also everything will be in green. Click save all, and you can see all of that is saved. You can press Ctrl-Shift-S to save all. Another thing is, make some changes. Another thing is, if I do debug, start without debugging, it's going to save your files out, do the compile, the build, and all of that stuff. So point is, it's going to save. Click start without debugging, and you can see this runs now, and it saved all of our files. So I just wanted to mention that stuff. It's going to basically save your work for you. Okay, so what we need to do next is, of course, we want in the header file here to paste back this function. And if I run this, it's going to give me an error. So the problem here is that these functions are in the global space. So this thing here, the name, is the identifier. And of course, we have two of the same identifiers in the global space. So that will give us problems. So just like I showed you with the file and folder demo, we cannot have that. Okay, we'll get problems. So I need to basically put these into folders if I want them to have the same name. So again, we use namespaces for that. So I'll do namespace, human. We want to create a named block of code. So again, the opening and closing curly braces are like the folder. And here, this is like the name. The main difference here, of course, is this is a namespace. So I'll just select that, paste that in here. Then we'll do one more for, let's say alien. Control X to cut, Control V to paste. So now I have human. Of course, we can define other functions in these folders now and do what we want. You will also notice that we actually have the standard namespace as well. Now there are various ways of including the standard namespace in this, but for now I'll just leave it like this. We can move on, keep it simple. I'll talk about that again a bit later in the video. So I'm back at my main function, and you can see we have an error. So identifier greeting is undefined. And you might think, well, that's weird, it is defined. And we have the header file included. So everything seems to work properly. It worked before, so why doesn't it work now? Well, as you might guess, we need to jump out of the current scope here if you want to access those functions. It's almost like a surname as well, right? When you have not just a name, but also a surname. So we have to go and look at this. I'll just save this here. You can see it turns green. And so we have global scope out here. And then we have to navigate, like go into whichever folder it is that we want to go and access the identifiers within those. So if you recall, we use the scope resolution operator for that. So because it's in the global scope here, and we include it at the top, that will also be available in our main function here. Now, actually what I'll do is, I'll just cut that IOStream out at the top. And I'll paste this in here in the header file just so I know that the file is included before we use cout. Okay. Back in my main, don't worry about that stuff too much at this point. In my main, I want to access those functions. So I can do human. Okay, so how do I go into that space, that subspace that we've created, or that subfolder basically? Well, I'll do the scope resolution operator, and now we can see this here, this IntelliSense. It shows like what is available. So I'll talk about this in more detail later. You can see that greeting here is available. Okay, so I'll just do greeting, Control F5 to run this. You'll see this works. But of course, we also want the weird one, scary one to show up. Okay, so of course, to access that one, we do alien. So again here, it's going to start the program, look for this, and then it's going to do the greeting. Same thing here, it's going to go into that folder basically, go into that scope, it's going to look for this subfolder or subspace, it's going to go inside of that to access the identifiers or the members within that code block, and we pass it the identifier that we want, in this case the greeting. Again, if I Control F5 to run this now, you'll see we get hello and hello humans. You can see we have hello and then a return, and then hello humans again and another return. That is what the end line is useful for, and we'll talk about that in more detail again in another video as well, but we can see that this works now. We can use the same identifier because they are like files with the same name, but they are in different folders. Okay, I have the Hello World demo open again that we wrote. So here we are simply printing Hello World out to the screen. And you can see we have std, the scope resolution operator, those two colons, and so on. So we basically have three ways of using namespaces. So this here is an example of explicit usage of namespaces. So we're explicitly like specifying the namespace. So the problem here is that we have to do it each time. So standard, colon, colon, cout, so on. Here the same thing with endline, right? That can be tedious and it can get repetitive. Another way of doing this is by doing using namespace. Okay, so instead of doing this, what we can say is using namespace std, and this you end off with a semicolon. Now what we can do is, of course this will still run, so Control F5, this still runs, but what we can do is we can now take this out. Those explicit namespace prefixes you can remove, Control and F5, and this will work, right? Now in general, this is considered bad practice because what's happening here is it brings in the entire namespace standard into this context. So in this case, it brings it into the global context. You know, that again is the global scope. So basically everything in here will now have access to this namespace. Now the problem with this is, of course, you can get conflicts. And one way to avoid that is you can do the using namespace, Control X, and then I'll do like this. And you can see that this will work now because we don't have any squigglies. We just had squigglies. So I'll do Control Z to undo the last operation. You can see we immediately get squiggly lines. Control Y to redo, again pasting that in here. And you can see those squigglies go away. Control F5 to run this, and this will work. Okay. So the point is you can also bring this in to a code block, and that means it will bring that in. So in this case, it brings in the entire standard library, basically. But that is only accessible within this code block. Okay, so that is more safe. So in other words, if you have two namespaces that you bring in, that might both have the identifier cout, as we have it here, then again, you'll get a conflict because the compiler just does not know like which one do you want to use. It doesn't have any indication. So in that case, you could still go about using the explicit version that we talked about previously. But there's another way. So I'll just go and do that. So instead of bringing in the entire namespace, we can do using, and then we can do a qualified namespace. We can bring in basically the identifier that we want. So we go into that context. So I'll say using std, and then I'll do the scope resolution operator to go into that scope. And then of course I'll just go and bring in the specific identifier that I want to use in my program. So in this case, let's do cout. And of course, you can see that we don't get squiggly lines here with cout, but with nline we do, because we haven't brought that in yet. So again, you can do explicit here, or we can simply bring that in. And you'll see that squiggly will go away. Control F5 to run. You'll see this works. We don't get any errors or warnings. And it basically says, okay, go in to the standard namespace and then bring in that particular identifier. So some function or whatever the case might be, bring that in. I'm going to use that in my program. Of course, you can also go and use that. You can see we get that red squiggly, so you can use that also in a particular code block. That might also be kind of better. You can see that squiggly goes away now. So again, this brings it in to the global context, basically, okay, the global space. Whereas here we are bringing it in, so it's only going to be used in this code block. Okay, so keeping things simple, we will probably use the using namespace std like this. But I would like to note and stress that that is often considered bad practice, because again, you can have conflicts. So basically just pay attention to that and kind of use what you need and when you need it. I'll go back to the previous project just for a quick demo again, the namespace demo project. Okay, we have this weird like alien greeting and so on. So we have again human greeting, alien greeting, and this again is the explicit prefix and namespace usage. Okay, so let's say we do this. We'll use the namespace human, and we'll use the namespace alien. Okay, so now we don't need to do this stuff anymore. Okay, now of course we'll get an error, because it's going to say that there is more than one instance of overloaded function greeting. Point is, if we run this now, we'll get errors. So one thing that you can do is you can go alien or human, and again you can see that this works. Or what you can do, instead of using the explicit one, is you can do this. So you can bring in into the code block like only the one that you want to use. Okay, hello humans. Or again, what you can do is you can do the qualified version of this. So, all right, Control F5 to run this, and this will work. So basically, you are simply bringing in this identifier from alien. Okay, so I covered a lot of material in this video, and I don't want you to worry too much about this stuff. Again, we'll cover functions in a lot more detail in a future video. The same thing with namespaces. There is still a lot more to talk about with regards to namespaces and future lessons, probably in module 2, because for the most part in the first module, again, we'll just use it like this. Okay, then we talked about a lot of these includes. We'll learn more of them as we go along, so don't worry about that too much as well. I just wanted to kind of stress the difference between these two, because when you are new, you might not really understand, why can't I just have one thing? Why do I need to do this using namespace and do some include, right? In a lot of courses, they kind of explain it, but it's not very clear, like exactly what's going on. So it can be confusing. It's like you're doing it just because they say that, you have to kind of do it, but you don't really know what's going on. So I wanted to take the time. It might not be super exciting, but I wanted to try and highlight again the differences. Again, you include some file and then you use some namespace. So this namespaces are again like an organizational tool, whereas here we are bringing in a file. We are specifying a file to use or to bring into our project. Okay, so I'm going to leave you with this and we'll continue in the next video.